Hello everyone, today is your class number 42. Class number 42 for your subject EMFT. Okay, so today I will start the numerical from the beginning. That means your first module, that is the vector analysis. Okay, so your numerical, there are several numericals are there which have to be completed today. So the first problem, right, let us consider problem number 1. Okay, so P problem number 1. So right, it is given that P vector equals to 2ax cap minus 3ay cap and Q vector equals to minus 3ax cap plus 4ay cap and find vector R equals to 2p vector plus 3q vector. Also find the magnitude of R. This is called magnitude of R. Okay, also find magnitude of R and direction of R. That means the direction of R means what? The unit vector along R. Okay, so sometimes this type of question may have been asked that also find the unit vector. This direction is nothing but the unit vector along R vector. Okay, so you have to perform this expression right first. Okay, so R vector equals to what? 2p vector plus 3q vector, right? So just put this p vector 2ax cap minus 3ay cap plus 3 times of minus 3ax cap plus 4ay cap. Okay, so sometimes this ax cap, ay cap also be in form of I cap, j cap, k cap. Okay, so 4ax cap minus 6ay cap minus 9ax cap plus 12ay cap. Okay, so 4ax cap minus 9, that means minus 5ax cap, and this one will be represent 6ay cap. Okay, so minus 5ax cap plus 6ay cap. This is your R vector, your first answer, answer number 1. Okay, so your answer number 2 is nothing, modulus of R, that is, so what is the modulus of root over of minus 5 whole square plus 6 square. Okay, so your answer will be 25 plus 36 unit. You have to written over here. Okay, so your answer will be 25 plus 36, that will be equals to root over of 61. Whatever the result, you can apply your calculator and you can get the exact value of it. Okay, so root over of 61 unit. So this is your second answer, answer number 2. And third one, that is R cap. So unit direction of this R vector, that will be R vector divided by modulus of R vector. Okay, so R vector equals to what? Minus 5ax cap plus 6ay cap. This is the definition of unit vector. Okay, so divided by root over of 61, that will be answer minus 5 by root 61. Please calculate it and you can get the exact answer. Okay, I actually left here. Okay, okay, so this is your unit vector. So this is your problem number 1, which is very much easy. Okay, which is very much easy. And next problem you have to find little bit tough, that means find the divergence of the following function. Okay, so problem number 1 is completed. So now I will move into problem number 2. Problem number 2. Determine the divergence of the following function. First one, p vector equals to x y square z I cap plus 2yz j cap plus y k cap. Okay, and second one, cos squared x, that is the q vector, equals to cos squared x I cap plus sin square y j cap plus e to the power z k cap. Okay, so these two vector you have to perform the divergence of it. So what do you mean by divergence? So divergence is nothing but the dot product of the vector with the del operator. So dot product of del will produce the divergence. Okay, divergence of p vector. Okay, so this divergence means what? This del operator is looking like del x I cap dot plus del y j cap plus del z k cap. Okay, this is dot with your x y square z I cap plus 2yz j cap plus y k cap. Okay, so your result will be this I dot I will be 1, j dot j will be 1, and k dot k will be 1. So del x and rest are 0. Del x of x y squared z plus del y of 2yz plus del z of y. Okay, here no I cap, j cap, k cap is present, are present. Okay, so that means it is a scalar quantity, and after deriving it, it will becomes, so here you can say, so x taken as outside as a common. So this one first you have to, so what, how to perform the partial differentiation? This is a partial differentiation, right? So this x and y squared z are 1 in it. So taking y squared z outside, so del x of x will be 1, right? And if taking x outside, and del y squared z will be 0. Okay, this will be 0 and it will be 1. So that means y squared z, only this term will coming out from this first derivation. Okay, so similarly from the second derivation we can write directly. Okay, so y taking outside as a common, or 2z first taking outside, so 2z taking outside, del y of y. Okay, plus, and now y is taking outside, del y of 2z. Okay, so this will be 1 and it will be 0. So this will be 1 means 2z plus 2z over here. Okay, and this will be 0, and lastly only y is present here, so that will be exactly 0. So plus 0 over here. So your answer will be y square z plus 2z. Okay, so this is your divergence of p. So now I would like to add one extra concept on this numerical, that you have to find the determine the divergence of the following function at 2, minus 1, 6 point. 2, minus y, 6, minus 1, 6. That means after calculating it, you have to put divergence of p at within bracket 2, minus 1, 6 equals to, that means x equals to 2, y equals to minus 1. So minus 1 squared into, and z equals to 6 plus 2 into 6. So your answer will be 1 into 6, that will be 6 plus 12, that will be 18 unit. Okay, 18 unit. So your divergence of p will be looks like this is your first answer, and now it is your second answer. Okay, for this A section. So A. Okay, within A you have to perform this one. Okay, so now I will move into B. Okay, what will be B? So B means this one. So you have to perform the same operation. Okay, so just writing this Q instead of P. So del x I cap plus del y j cap plus del z k cap dot product with cos square x I cap plus sin square y j cap plus e to the power z k cap. Okay, again you have to perform the same operation. So directly I am writing the ultimate answer over here. So your answer will be, if we derive it with respect of x, this cos square x, it will be 2 cos x into minus sin x. Okay, okay, then plus del y of this one, it will be 2 sin y into cos y. Okay, plus del z of z means e to the power z. Okay, so at the point del divergence of q, at the point 2 comma minus 1 comma 6, your result will be 2 into cos 2 minus sin 2. Okay, plus 2 sin, or you have to write some first the formula. You have to make a formula. Okay, so minus sin 2x, right, because 2 sin x cos x means sin 2x. Okay, plus sin 2y. Okay, plus e to the power z. So now put x equals to 2, that is minus sin 4 degree. Okay, plus sin minus 2 degree plus e to the power 6. So ultimately just put it in calculator and get the exact answer. So your answer will be this unit. Okay, so this is your divergence. Okay, problem number 2. So I will move into problem number 3 now. So I will move into problem number 3. So determine the curl of the vectors given below. Determine the curl of vectors given below. For A, p vector equals to e to the power x cos x I cap plus sin z k cap. Okay, and second one, q vector equals to e to the power x cos y I cap plus sin square y cos z j cap plus cos x sin square z k cap. Okay, so you have to perform the curl. So what is the curl? So curl is nothing but the cross product of this vector field with the del operator. Cross product of this vector field represents curl of the vector p. Okay, so you can perform the curl by producing the determinant method. Okay, or you can say the direct methods are there. I have already been discussed. So please do the class again and see my video. Then you can easily get the concept of curl. Okay, so now I am directly writing over here. So this is the curl method. This is a method of curl. Okay, that means what is the, so del x I cap. So you have to perform this one. Okay, and p vector means this one. So e to the power x cos x over here, and there is no j part, that is 0, and for z part sin z only here. Okay, so what will be your determinant multiplication? So I cap taking common, del y of this one, del y of sin z. Okay, minus of del z of this one, del z of, sorry, this one, that will be 0. Okay, so plus, sorry, taking minus j cap now. So this one, this column and this row, del x of this one, del x of sin z, del x of sin z into del z of e to the x minus del z of e to the power x cos x, e to the power x cos x. Okay, and plus k vector multiplied with this column and this row eliminated. Del x of 0, del x of 0 minus del y of e to the x cos x, e to the x cos x. Okay, e to the x cos x. So now derive. See, I cap taking outside, so del y of z, it will be 0 because there is no y part, and the derivative of 0 term is also 0. Okay, and del x of z, it will also be 0, and e to the x cos x, so with respect of z, so it will be again 0. So 0 minus 0 over here, minus j cap taking outside, so 0 minus 0 also there, plus k cap over here, it will represents del x of 0 means 0, and del y of e to the power x cos x. So e to the x cos x, that means again it is 0. So it will be 0 I cap plus 0 j cap plus 0 k cap, right? 0 I cap plus 0 j cap plus 0 k cap, that will be 0 vector. Okay, so please put the vector sign over the 0. Okay, unless you putting this 0 vector sign over this 0, you will be you will be punished by some marks. Okay, so some marks will be deducted, okay, for you. So curl of P will be equals to 0 vector, right? Because this curl of produces a vector quantity which is called the which have the magnitude in all direction is 0. That is it is a null vector. Okay, that is, it is a null vector. Okay, so next you have to perform the same curl operation for the second one. So just changing here, so I am changing the so e to the power x cos y. Okay, next sin square y cos z, and last cos x sin square z. Okay, so at again 0 comma minus 1 comma 3. Okay, so find the result at 0 comma minus 1 comma 3. For this case, all for this p vector, all the components of the curl will be 0. So that's why if we want to put the value again, it will be remains 0. Okay, so no change will be taking place. So for this case, I vector taking outside as a common, del y of this one. See here, there is no y part is present, right? There is no y present, so directly I am writing 0, and minus del z of this one. So here is a z part. Okay, so del z of this one means if we consider the cos z taking outside common, then sin square y will be 0, and if we consider sin square y is taking outside, so your result will be sin square y taking outside, and ddz of cos z will be minus sin z. Okay, so this is your I vector. Okay, so minus, then minus j vector of j vector means this column and this row. So del x of this one, so sin square z taking outside as a common, sin square z taking outside as a common, and cos x will be minus sin x. Okay, the cos x, derivation of cos x will be minus sin x, and negative sign of, so del z of this one, so e to the x cos y, e to the x cos y, there is no z part, so directly you can we can put 0 over here. Okay, plus k vector. So what will be your k vector result? So this column and this row are eliminated now. Del x of this one, here is no z x part, so it will be directly written 0, and del y of this one, only cos y is there, so e to the x cos y, so only y part is cos y, so e to the x taking outside, and cos y will be minus sin x. So e to the x taking outside is a common, and cos y equals to minus sin y. Okay, so your result will be minus, negative will be positive. So sin square y sin z I cap minus it will be again positive, it will be sin square y sin x j cap, and minus it will be again positive, so e to the power x sin y, e to the power x sin y k cap. Okay, so now the put this value 0 comma minus 1 comma 3, that means x equals to 0, y equals to minus 1, and z equals to 3 on this formula, that is curl of q equals to this one. So if we want to put the z x equals to 0, then this term will be 0, and if we consider x equals to 0, then this term will be vanished, that is y 1. Okay, e to the 0 means 1. So your result will be sine square y means minus 1, that means sine square minus 1, sine square minus 1. So your result will be sine square minus 1 sine 3 I cap. Okay, and j cap will be vanished. Okay, and e to the j x means e to the 0, that means 1 into sine minus 1 k cap. Okay, so just put it in calculator, you get the exact answer. Sine square minus 1 sine 3 I cap plus sine minus 1 k cap. Okay, so this third problem is also completed. So I will move into the fourth problem. Okay, problem number 4. Okay, so next problem, prove that vector field P vector equals to yz ax cap plus xz ay cap plus yz ax cap plus xz ay cap plus xy az cap, xy az cap. Okay, xy z cap is a irrotational and solenoidal. Okay, so irrotational and solenoidal, what do you mean by the term irrotational vector and what do you mean by the term solenoidal vector? Okay, so irrotational and solenoidal means, irrotational means if the curl of that vector, if it is 0, then P vector is called irrotational. Okay, and the solenoidal concept, if divergence of P equals to 0, then P vector will be called solenoidal. Okay, so these two concepts. So curl of P means what? So you have to perform the curl of P and you have to verify it will be 0. Okay, with irrespective of any point. Okay, so curl of P, if we perform this curl of P, then I vector, j vector, k vector will be there, del x, del y, and del z will be there, and del x means yz, del y means xz, and del x means xy. Okay, so your result will be taking out I cap over here. So del y of this one will del y of xy, okay, minus del z of xz. Okay, so next j cap by taking this column and this row will be eliminated. Del x of xy minus del z of yz. Okay, so plus k vector, so k cap will be equals to, or in this case you have to given axy, ax cap, ay cap, az cap. Okay, so you can write also ax cap, ay cap, az cap instead of I cap, j cap and k cap. Okay, so if you wish you can write also. Okay, but here I am ignoring it, and for your case you may write it ax cap, it is ax cap, it will be ay cap, it will be az cap, and this, for this case it will be ax cap, for this case it will be ay cap, and for this case it will be az cap. Okay, whatever. Okay, so it is not immaterial. Okay, so az cap equals, az cap by taking this column and this row will be eliminated, del x of xz minus del y of, this is del y of yz, right? Okay, so del y of xy means what? Your result will be x. Del y of xz means again x. So it results I cap taking outside x minus x, right? I cap taking outside x minus x. So similarly I think next term will be j cap taking outside. So this will be y and it will be again y. So y minus y, and last obviously it may have del del x of this, that means z minus z. Okay, so your result will be 0 because 0 vector. Okay, so curl of p equals to 0 vector because 0 I cap, 0 j cap, 0 k cap. Okay, so curl of p equals to 0 vector. That means you can here conclude over here the p given p vector is an irrotational vector. Given p vector is an irrotational vector. Okay, and next one is solenoidal. So what do you mean by solenoidal? So solenoidal means nothing but divergence of p should be equals to 0. Okay, so you have to check the divergence of p. So how to check the divergence of p? Divergence of p means del del x I cap plus del del y j cap plus del del z k cap. Okay, so making a dot product, that is yz I cap. So I am writing here I cap. Okay, so no problem, you can also write this I cap xy into k cap. Okay, so and if you wish to remains this is ay cap is ax cap ay cap az cap remains same, then please change here this del operator as del del x ax cap, del del y az ay cap, and del del z az cap. Okay, so this one multiplied with this one, and del del x of yz, del del x of yz over here plus del del y of xz over here, and on last term del del z of xy over here, and rests are 0. So there is no x part, so it will be 0. There is no y part, again it will be 0, and there is no z part, again it will be 0. So 0. So divergence of p equals to 0. That means it is a solenoidal. Okay, so here you can conclude that the vector p vector is a solenoidal. But p vector is a solenoidal. Okay, so this is your problem number 4. Okay, so today's last problem, your problem number 5. I will start now. Okay, so okay, problem number 5. S equals to x square y plus 3y square z square minus 2x square z cube. Okay, 2x square z cube, x square y plus 3y square z square minus 2x square z cube. Okay, find Laplacian at 1, 2, minus 1 point of S. That is, S is a scalar quantity. You can check that it is a scalar quantity. Why? Because there is no I cap, there is no j cap, and there is no k cap is present. Okay, so that means what is the Laplacian? You have to first perform the Laplacian. That means divergence of gradient of S. Divergence of gradient of S. Okay, so divergence of gradient of S. So first you have to perform the gradient of S. Okay, so what will be your gradient of S? So divergence of, this is a Laplacian, right? This is your Laplacian of S, only scalar. Okay, it is a scalar. So Laplacian means your del del x, this s I cap, plus del del y, this s j cap, plus del del z, this s k cap. Okay, so you have to perform the del del x of x means what? You have to differentiate partially with respect of s or with respect of x now. So if we derive del del x of this one, it will be x square y, that means 2xy I cap, or there is no x part, so there is x part. Okay, so 2xy minus, so it will be 4xz cube I cap. Okay, plus del y of again is y with respect of y, so it will be x square. So for this case it will be x square, for this case it will be plus 6yz square, x square plus 6yz square minus 0. Okay, so it will be j cap, and last one plus for del z of s, so z with respect of z it will be 0, with respect of z it will be 6y square z minus 6x square z square k cap. Okay, so now this is your gradient of s. Okay, this gradient represents here scalar, gradient represents gradient of any scalar represents vector. So this is a vector quantity because I cap, j cap, k cap over here. So if we expand this del operator over here, so if we want to expand this del operator, then what happens? Del x I cap plus del y j cap plus del z k cap. Okay, making a dot product with it. So what will be the dot product result? So your dot product results, I cap and I cap remains 1. So del x of 2xy minus 4xz plus del y of x square plus 6yz square plus del z of 6y square z minus 6x square z square. Okay, so del x of this one means 2y minus 4z, right, plus del y of this will be 0 and it will be 6z square. Okay, plus, and for this case 6y square and 12x square z plus 12x square z plus 12x square z. Okay, so if we want to put the value of this 1, 2, minus 1 point, 1, 2, minus 1, that means, so 1 x equals to 1, so for this case x equals to 1, y equals to 2 and z equals to minus 1. Okay, so y equals to 2, so if we put y equals to 2, so 4, z equals to minus 1, then it will be plus 4, right, and z equals to minus 1 again, so it will be minus plus 6 plus y, that means 2 square will be 4, 4 into 6 24 plus 24 plus 12x square, that means 1 into minus 1. Okay, so minus 1 into 12, that will be minus 12, it will be minus 12. Okay, so your result will be 4 plus 4, that will be 8, 8 plus 6 14, 14 plus 12 24, 28, 38, 38 minus 12, 38 minus 12, your result will be it will be z equals to minus 1, right, so it will be, okay, it will be minus, right, it will be minus because this one minus over here, so it will be minus, so it will remains positive. Okay, so your result will be 50 unit. Okay, your result will be 50 unit. So after calculating it, you can get the result will be 50 unit. So today's 5 numericals are over. So these 5 numericals are very much important for your first module, that is vector, and for the second module, yeah, we can start from for the second module in the next class, that is class number 43. So wait for that time. I will come with the second module numericals, that is your coordinate system. So today's class up to this much, and thank you. Okay.